Hind student. In the previous lecture of this multiplex system unit of telemetry principles, we understand about the pulse code modulation and time division multiplexing pulse code modulation multiplex system. As I told you in the previous lecture, in pulse code modulation we have 3 steps: sampling, quantization and encoding. And after these 3 processes we will get a pulse code modulated signal. Means this analog signal will be converted into 1010101 form of digital signal, where new bits can be used to represent this analog signal. And also I told you the bandwidth of pulse code modulation system is NFM or nu FM, where FM is the frequency of the analog signal. It means if the number of bits are increasing from 2, 3, 4, 5, similarly the bandwidth is also increasing. To remove this problem, some derived pulse code modulated techniques can be used, and that techniques are delta modulation, adaptive delta modulation or DPCM. These all are techniques present here. Before starting the DPCM, I want to give you some idea about this delta modulation and adaptive delta modulation, because it is required here. In delta modulation system, actually we are decreasing the use of number of bits. In pulse code modulation, we are using n number of bits for encoding the analog signal or for encoding a individual sample. But when we are talking about the delta modulation scheme, we are using only 1 bit for the quantization or encoding of a individual sample. Means one sample 1 bit, that will directly cut down the bandwidth requirement. As n become 1, then the bandwidth will be equal to FM, means the input analog signal. Now, how it is going to be done? To perform this, what we are doing here, in the pulse code modulation scheme, we have samples. We take the individual sample, then perform the quantization, get the XQNTS and then perform the encoding. But in delta modulation, what we will do? We only compare the samples. We compare the present sample with the previous one. If the sample is increasing, we will transfer 1, or if the sample is decreasing, we will transfer the 0. Means if I am taking this example, here this one is the present sample. If this is the present sample, it will compare with the previous one. You can see that the previous sample is here, means the current sample or the present sample is higher than the previous one, means sample is increasing, 1 will be transferred. For this position, what will happen? For this position, sample is again compared with this previous one, and what will happen? You can see that the sample is again increasing, again 1 will be transferred. In the third part, this sample, in this sample when compared with this previous one, you can easily see here the sample size is decreasing, means now we will transfer 0. You can here understand one point, for each sample we are sending only one bit. If the sample is increasing, then the 1 is transferred, if the sample is decreasing, 0 will be transferred. The only function that is used in delta modulation is comparison of sample, present sample with the previous one. But in this complete process, the step size del, I told you the del is 2xm upon L, L is the number of levels. In the delta modulation or in the pulse code modulation, this step size del, it is fixed in which PCM and delta modulation. But due to this fixed step size, what will happen? Because of this fixed step size, two type of distortion will occur in the delta modulation scheme, and that distortions are slope overload distortion and granular noise, that you already studied in your previous semester in communication engineering part. Then if you can change this step size as per the sample value, then these problems of slope overload distortion and granular noise can be removed. That is why the ADM come into the picture. ADM denotes the adaptive delta modulation, means now the step size will be adaptive as per the sample signal magnitude, means you can vary the step size, and that is why in this process we are getting the quantization non-uniform quantization, because in the pulse code modulation and the delta modulation scheme we are using only the uniform quantization, because the step size del is fixed. But in adaptive delta modulation we are changing the step size as per the input sample, that is input sample value, that is why here we are using non-uniform quantization. So, these are the three techniques: PCM, DM, then ADM. Each technique is resolving the disadvantages of the previous one and getting a new technique. Requirement of bandwidth will be decreased by DM, slope overload distortion and granular noise problem will be overcome by the ADM, but now a new problem will arise. What is that problem? You can see here, if you are using some this kind of sample value, you can easily observe here one point, when we are comparing this sample with this previous one, you are transferring 1. For this sample you are transferring 0 because the signal is decreasing. For this sample again you are transferring the 0. For this you are transferring the 1, but after that all that samples are somehow equal in the amplitude or approximately equal in the amplitude. That is why after comparison you will get the same redundant information again and again and again, means a long stream of 1 1 1 1 will be there, or the redundant information is there. That can also happen in the form of 1 1 0 0 0 0 0 0 1, means after removing the bandwidth problem, after removing the slope overload and granular noise problem, you can have a new problem, and that problem is redundant information. To overcome that redundant information, this DPCM system, that is differential pulse code system, came into the picture. I already told you about this pulse code modulation, and this is the diagram of that. These are the basic steps that is again used in the same technique. So, in the differential pulse code modulation, here problem is we have a long stream of ones or zeros, which will create a confusion in the form of redundant information. So, easily understand by this language that differential pulse code modulation is a technique of analog to digital signal conversion, and this samples the analog signal and then quantize the difference between the sampled value and the predicted value, then it encode the signal to form a digital value. Means this is the main concept behind the DPCM. Means here you are getting this redundant information and you want to overcome this problem. To overcome this problem, you have this differential pulse code modulation system. What you are doing here? In this differential pulse code modulation system, actually you are comparing the present signal with the previous one, and after comparing you will get a error signal, and now you are performing the quantization on that error signal. Here understand very clearly, in the pulse code modulation system you are directly taking a sample, then performing the quantization on it and then performing the encoding, and you are getting new number of bits. But in delta modulation you are comparing the present sample with the previous one and getting the increase or decreased value and sending number of bits 1, that is 1 or 0 for the increase and decrease respectively. But in the differential pulse code modulation you are taking the both samples, you are taking present sample, comparing it with the previous sample and getting the error signal between them. Now, the quantization will be done on that error signal. So, here you can understand that sampled input, this is the sampled input, that is the present input, this is the XNTS, means the previous one or the predicted value. Here predicted value come from the feedback part, this is the feedback part of the DPCM. We are getting the previous signal or the predicted signal from the previous one. So, you can understand here this language that in differential pulse code modulation, the difference between the sampled value and the predicted value, between the sampled value and the predicted value, you are taking that difference, then a new difference, that coding a difference is based on the fact that most source signal shows significant correlation between successive samples. So, encoding uses redundancy in sample value, which implies lower bit rate. Means due to this process what will happen? Previously you are getting these redundant information in the signal, but after using this predictor filter what will happen? That predictor will predict the sample from the previous sample and compare this with this sampled input. For this complete arrangement will be made. Here we have the signal xt. After performing the sampling we will get XNTS. That XNTS is applied to a summer where we are getting the previous signal from the predictor, and that is XCAP NTS, and getting the error signal or error sample, that is ENTS. Then that ENTS is quantized and we will get new NTS, that is the output signal. To perform the next step, that same output will be applied to through this predictor feedback circuit towards the input summer part, and again we will get the error signal for the new incoming present signal. Similarly, this process will be go on one by one, and this complete process will decrease the use of number of bits for a individual sample, because now you are only encoding the difference of the samples, not the complete sample. That is why the number of requirement of the bits will be lower down by 2-3 bits. So, that is why in the differential pulse code modulation, our that problem of redundancy is removed also with the lower bit rate. Similarly, at the receiver side of this differential pulse code modulation, just the reverse process will be done. We are getting the BNTS input from the DPCM transmitter part, and we are decoding this signal through this decoder and getting the decoded output through this predictor feedback circuit to perform the complete prediction process and to recover the original signal back. So, when we are talking about these all techniques, you can understand here some points very clearly. First problem of redundancy and higher bit rate of PCM, both will be removed through DPCM system. You can also compare it in terms of various parameter, as if we have techniques such as PCM, DM, ADM and DPCM. This technique is the complex one, but these techniques are quite simple. Then in the pulse code modulation, you only taking the sample and getting it encoded for the output, but in delta modulation you are getting the comparison of present sample with the previous one, and as per that comparison output, if the sample value is increasing, you are sending 1, if sample value is decreasing, you are sending 0. But in the both cases, the step size del is fixed. Due to that fixed step size, you are using uniform quantization, and because of that uniform quantization, you will get the problem of slope overload distortion or granular noise, which will create distortion. To remove that, we are using adaptive delta modulation. In adaptive delta modulation, we are using a variable step size, means here we are using non uniform quantization technique. But all these three techniques have a problem of bandwidth plus higher bit rate, because bit rate is higher, then bandwidth will be also higher. To moderate that value, that DPCM came into the picture. As far as bandwidth is concerned, maximum frequency is used by the pulse code modulation, so bandwidth is used by the pulse code modulation, and minimum is used by the delta modulation or adaptive delta modulation, because here bit rate is only 1 bit per sample, but here we are using new bits for per sample. But in DPCM we are using more number of bits than the DM and ADM, but less than the PCM, means the bandwidth is moderate with improved efficiency, with improved efficiency. This comparison is also a very important question in the university examination. So, you have to be very clear about this comparison, that is why I told you all these parameters. So, first parameter is the complexity, means PCM is quite complex, DM, ADM and DPCM is quite simple. When we are talking about the efficiency, DPCM is the highest efficiency. When we are talking about the number of bits used by the system, PCM using 2, 3, 4, 5 or 16 bits for the system, whether ADM and DM using only 1 bit, but DPCM using 2, 3 or 4 bits only. Similarly, bandwidth requirement is also maximum for the PCM, minimum for the DM ADM and moderate for the DPCM. So, this is all about the comparison of digital modulation technique, and to end this unit second, I want to conclude all these things today, because in the next lecture we will start the third unit, and that is related to the modem. So, in this multiplex system unit we concentrate on the multiplex system, and multiplex system is basically combination of multiplexing plus modulation. As far as telemetry systems are concerned, you understand point, you can understand that point, you are getting the data from the remote location and you are getting n number of data, because various sensors are located at that point, remote location, and that all data should have been multiplexed on a single channel and also have to be sent to a distant location. So, modulation is also required. So, combinedly multiplexing and modulation, we will design a multiplex system. There are two types of multiplex system present, analog and the digital. For the analog multiplex system, we use analog multiplexing technique and analog modulation technique. In telemetry system, we basically concentrate on FDM, frequency division multiplexing, for the analog part, and for the analog modulation we will mainly concentrate on FM. That is why the FM FDM multiplex system came into the picture. For the FM we are using direct method or FM circuits for the generation of the signal. In the previous lecture I told you about that. We are using varactor diode or the variable reactance devices for the direct modulation or direct frequency modulation. For indirect method we are using that Armstrong method, in which we are using the relationship between phase modulation and frequency modulation for generating a frequency modulated signal. But as far as analog multiplex systems analog multiplex system are concerned, you are using frequency multiplexing, frequency division multiplex system, and these are applicable for the analog telemetry systems. But when we are talking about the digital part, you can use the time division multiplexing for the multiplexing part, or modulation you can use that PAM, pulse amplitude modulation, or pulse code modulation, or DPCM. These are our basic multiplex systems. Always remember all the parameters which I told you earlier, such as number of bits, requirement of bandwidth, efficiency. These all terms are play an important role in the selection of a multiplex system for a specific telemetry system. So, these all points are related here, and we concluded this second unit of your telemetry systems. Now, we proceed towards the third unit of a telemetry system, in which we concentrate on the modem part, because I told you in telemetry there are three parts: transmitter, channel and receiver. At transmitter we will perform these modulation, demodulation, multiplexing, all these points. At receiver side we will perform demodulation and the demultiplexing. But when the channel came into the picture, means you have to put the data from transmitter to on the channel. That is why we will concentrate on the channel, and when we are talking about this channel part, this modem came into the picture, and that modem stand for the modulation demodulation unit. So, that is all for the second unit of telemetry system. Then in the next lecture we will concentrate on modem. Till then, thank you.